This is our previous example, dice roller, where I added cookie feature. And we don't need to reclone it, we just need to open what we already have, and we can download difference directly from the project. Or if you didn't clone this before, just clone it. So I will open dice roller from the hard drive the way how we cloned it before, from the place where we cloned this before. So I open, and it is your section folder and dice roller. If you check branches, you won't see cookie-related branch because I created this after your lesson was over. In order to see difference, we need to synchronize with GitHub. We need to click this button. And this way you will see updates on GitHub because currently it doesn't know. This button is called fetch. It now Git, locally installed Git on your hard drive connects to GitHub, and it shows that branch main and branch fancy model was updated slightly. It's not serious updated, just newer version of library. And it still doesn't show additional branches. I don't know why, but it doesn't. So you click outside and click again, and it will show. Okay. After clicking outside and clicking inside, main, you will see additional branch using a cookie and also 5 fancy cookie encoders. So we got new data, but main and fancy model still shows that we need to update. So let's run update on local branch main. It means click update, and it will download the difference and does update for main. Says one file updated and commit, and this actually just update different library version. In fancy models, the same update. So this is how to do update from GitHub. It's also a learning experience, not just. Next, I want to switch to branch code using a cookie because it is simpler than several encoders. So switching to using a cookie, check out. So as already mentioned, it's previous code with extra feature of using a cookie. So let's run it and see what it does. So it started. Next, I'm going to localhost 8080. And it crashed it. I don't know why. I know why. Because I ran this in the morning, and I have several versions of the code that is using different cookies, different cookie data. And one of the versions of my code is in conflict with this version. So it grabbed the cookie, tried to make sense of it, and crashed it because it's different data. Okay? You won't have this issue. So I need just to remove that cookie that is messing this up. So Control-Shift-I stands for inspection. I will find the cookie and I will delete it. So after this, if I go localhost 8080, it's fine. And because I have several versions that save data inside of a cookie differently. So it picked it from previous, another run, and crash it. So let's run it and click roll. Now it shows the result of the roll. And if I close browser and open it again, or I just go to localhost 8080 again without any inputs, it shows saved data. So the way how I code it is to save data inside of a cookie each time. So when we return to the application, either after closing browser or just going to address without roll, it will show previously generated data. Where is it stored? It is stored inside of cookie, and cookie is inside of browser. So how does it work? When we create a cookie, we add it to response physically in our code, add it to response. When response is received by the browser will find the cookie, store it internally in some either file. Years ago, it was just separate file per cookie. Now it could be different. So it is stored on your in folders of browser, and it is key value storage. So you can have as many cookies as you like per application, but not as you like. It's limited. Sorry, it is limited. There is some limit for number of cookies per site, and it is enforced by browser. If you are curious, look up. If you think that you may run out, it is a reasonably large number. If you send 5 cookies, you are fine. So it's not as many as you like, but it is it's enough, I would say, enough. So it is key value storage. So every cookie has a name, so it works as a key, and value is a string. But not every character is allowed. Spaces, for example, not allowed. So we have to, when we save data inside of a cookie, we have to do either some automatic conversions that will get rid of the characters that are not allowed and replace it by some naming convention, and do conversion backwards, or just do your own trick. What did I do here? As you see, I just joined numbers together to have a string. Since they're single digits, it's not doing any contradiction. If it is more than 1 digit, maybe I would have to do some separations in between, but not space, something else. And if I roll it again, you will see that raw data is different than it's matching. Okay. So how does my entire program is on server side? Right? This is how we write all code in this course before midterm. Everything is on server side. Cookie is in a browser. A cookie is added to response, browser receives it and store it. So how does the server get the cookie? It gets it automatically. After browser got the cookie, browser will send cookie in every request to this application. Again and again, no matter where, again and again, each time it will send the cookie. It is limited by path. If path is slash, it means to any address of this application, any request to any address of this application will contain the cookie. If you limit to some virtual folder, like your application has virtual folders, for example, inside of your address, some folders inside of your address. So this way you can limit scope of your cookie to some virtual folder. So you save some traffic, small saving of traffic. If you limit cookie path, so this property of a cookie, call it cookie path. This is how to limit traffic of cookies if you associate cookies with specific folder of addresses. So cookie will always come back within the path. So what else do we have here? We have expiration time, right? In this case, it's set tomorrow, and it's not. This is because I coded it inside of the program. I set expiration in 24 hours after it is made. Browser calculates it and set times to expire. Next, size. It's probably just in bytes. It looks like it is just in bytes. What is this HTTP only? This field is called HTTP only. This cookie, it is set by IDE. It is HTTP only, but this is not. If we look up session ID cookie, it will be HTTP only. I didn't discuss it before, but you can run previous program. You will see that it's HTTP only. If you create cookie by default, it is not check marked because it's by default it doesn't matter. This is why it's not check marked. But if it is session, It is check marked. If it is session ID cookie, it is check marked because a session ID makes sense only for the server side. You don't need to read it by JavaScript in your program. Because session ID is used to match in-memory storage associated with your browser, right? So it does make sense only on the server side, and JavaScript doesn't need to know it. And there is additional security precaution. It is on as-needed basis, right? JavaScript doesn't need to know it, and it would be even worse if JavaScript can read it. Why? Because session ID is used to access session data, right? It's session ID cookie is used to access session data. And login information by default is stored inside of session. So it is related to login security, potentially. Session ID potentially related to login security. So for this reason, session ID is hidden from JavaScript. Why do we need to hide session ID from JavaScript? Because JavaScript, it is not necessarily only the JavaScript that we wrote it for ourselves. If program has security issues, like security holes, hackers can insert JavaScript at the time of the transmission, so this JavaScript will run on the browser and potentially steal cookie. If cookie is not HTTP only, or some other security information. So it is HTTP only, it is for extra protection, so JavaScript inserted by a hacker cannot access it. Or in general, JavaScript cannot access it. So this is the meaning of HTTP only. Another setting sets it secure. If it is set secure, it means it will be enforced by browser, transferred only in HTTPS protocol, HTTP, only through encryption channel. If it is session ID cookie, expiration will be session. So when browser is closed or the session expires, whatever comes first. The rest is not as important, so look up if you want. So this is behavior from outside. How to encode cookie? I already mentioned that it's you can just do a hack, as I did, by joining numbers, but it's definitely a very specific case, right? Doesn't always work. We can use a general approach. We can use encoders to convert anything what we like into something which is accepted inside of cookies. So it's not a big deal, essentially. Cookies are limited by size, so we cannot store large information inside of a cookie. If you think that you may run into such issue, look up documentation how big is cookie could be. So let's see how this is done inside of the code. So game controller. I need, as you probably realize it, that I need to convert sequence of integers into the string which is just those integers are joined, right? Those digits are just joined. And I need also to have some simple algorithm to split it, the string into numbers and convert this into list of integers. So it is a little bit slightly messy logic, and it is related to not business logic, but separate logic from GUI logic. So I decided to separate it to controller, to separate service. And I call it cookie data service because it's dealing with cookie data. So when I when system generates controller, by calling constructor, now it needs two services. One, it is as before, roller data service, and one, it's also additional service. Now it is necessary, cookie data service. So it will convert data acceptable in cookie to the data acceptable cookie and backwards. What do we need? We need something that satisfies given interface. We got raw data, and this method is converting this to string acceptable inside of a cookie. And we need to convert it back. We get string acceptable in a cookie and convert it to raw data backwards. So if we implement this interface, idea would work. How would we implement it? It's our choice, because this is what my controller needs. So this is, from controller point of view, this conversion is necessary. But how would you handle the conversion? It's not important, right? As long as it works. Okay. So what did I do for that? I implemented this by brute force. So get values of raw data will give me list of integers. And now I just want to build a string out of these digits. And since this course is not just about web programming, it's also about learning Java, so let's learn how to do this efficiently in Java. In Java, we can join strings by plus sign. But if we need to join more than one item, like having this in a loop like here, it is not the optimal one. It is not the optimal approach because in Java, strings are not modifiable. Strings in Java are immutable objects. It means each time when we join two strings, it will produce new string and discard previous one, unless you assign it to the variable. So having this manipulation in the loop, it's not efficient. So if specifically for efficient joining strings in loops, or by just join sequence, and Java provides class called string builder. String builder is not recreated by adding things. For this, it is more efficient than plus in a loop or in long sequence. So I created string builder and told the constructor how long I expect it to be. If we have no idea, we just leave it empty, and it will try to get some length, and if it is too small, it will just later allocate longer lengths and copy previous one into longer one. So this is not optional. This is optional because it's just a guess for optimization. How long we expect this to be. Next, I'm running for each loop from list of integers. If we can use int to refer to integer, because this would be unboxing, right? Integer, it's a class wrapper around int. So it's like a box around int. So when you take it out of a box, it's unboxing. So conversion from integer to int, it's unboxing. Conversion from int to integer, it's like a wrapping in class around int, simple type. This would be called boxing. So it is unboxing. And I keep appending this value to the builder, right, in a loop. And return builder to string will convert it to string and return it as a string. Okay. So this is how to build strings efficiently in Java if you need a loop or you need to join many strings. How to go back? Now I have a string, and I need to get a list of integers. So length of the string would be the same as list of integers, length of the list of integers, because they're single digit numbers. So length of the string, it's length, and a pre-allocated array inside of array list object. And again, it's optimization. If you don't provide guess for the length, it will just do its best, and if it is too small, it will copy it later. So I got values. Now I'm running loop, picking character at location I, index of the loop, right? But I cannot convert it directly to integer because this method parse expects string, not character. It's wrong type. So I convert character type to string, and after this I parse it to get int, and it is joined to the list. Okay. So after loop is over, I will get list of integers. Okay. And now I have a list of integers. I call constructor of implementation the interface. Raw data its interface in this case. So I call constructor that a constructor of a class that implements this interface. So I got raw data object and I can return it. Okay. So although it is very specific task, when we look it through the code, we learn something extra useful, how to deal with strings efficiently in Java. Right? If we need to join strings. Now let's see how it works inside of the controller. So this implementation is injected. If we look at dice game, we will see that we have two additional parameters. One, it is response object, and second, it is cookie. What is response object is about? HTTP servlet response and HTTP servlet request, they are lowest level API available in Java web programming. How does it work? When we have web application exchange with browser messages, web messages, right? Browser sends request, server generates response and sends to the browser. Next, browser sends new request and receives new response. So this is how server-side application interacts with the browser. So if we need the lowest level API possible, if we do, and we just add it as parameters of methods of controller, and system will give us these objects. Everything received from the browser will be wrapped inside of HTTP servlet request object. And everything that is going back will be wrapped inside of HTTP servlet response object, including HTML. But wrapping HTML, in this case, handled automatically by template processing engine. So we don't have to worry about it. But adding cookie, we have to deal with this directly. So for this reason, I have a reference to response object to add cookie explicitly to response. So cookie will travel to the browser. So this part, it is to send cookie. Adding this to response means give it to the browser. Okay. This part, it is for receiving cookie. So in order to receive cookie, we need to specify name of a cookie. Default is optional, but if you don't provide default and cookie didn't come, it will crash your program. So for this reason, it's better to provide some default. So this would be actual string that came inside of the cookie. All right? Next, let's see. Is roll it will be true when we click roll button. So I click at roll button. It comes is roll it as true. Okay? And when it is roll it, I'm not displaying data from the cookie, previous cookie. I'm displaying new data. Right? But I'm displaying new data and I'm creating new cookie with new data. Okay? So if isRolled is true, I need to display new data and I need to create new cookie this time with new data, this data, right? See, roll, new data, and cookie will contain new data. So let's see this logic. isRolled, this is roll data generated here. Then I print it, so I got message roll data 5, 6. Okay, this is roll data, total 17. Then I created cookie name, and converted roll data to the string that I want to store inside of a cookie. So creating cookie object is calling constructor of a cookie object. But this cookie object is not added to response yet. Before you add it to response, you can change other parameters of the cookie. For example, expiration time. Expiration time is set in seconds. So this is why I have 24 times 60 times 60. Please notice that it's not less efficient because all modern compilers can and will do constant folding. So this is called constant folding. When we have some operation with constants, it will be calculated by compiler, and compiler will replace it with the result. So it doesn't make sense to calculate this on calculator and put it result. It won't be more efficient, but it will be harder to understand for another person looking at the code. Right? So for this reason, I leave it 24 times 60 times 60. Compiler will take care of it, so I don't have to worry about it. It will not be recalculated each time. And I add cookie to response. That will do the trick of sending cookie to the browser, because all data from the response object will be sent to the browser. So what happens next? And the rest is the same, but what if isRolled is false? If isRolled is false here, or nothing at all, because if it's nothing at all, it is false by default. So if I send nothing, it will be false by default. How do I know? Because it's here. isRolled default is false. Okay. And if isRolled is false, or when you go to localhost 8080, I'm reading the cookie, and I'm creating the data from the cookie, and I'm displaying the data. So in this case, I will be here. isRolled, else. So this is not rolled. In this case, it will be display this. Dice is not rolled. Debug. If cookie value is empty, it will display this. And display template without dice. But in this case, it found cookie, right? In this case, it found cookie, so it displayed this message because cookie value is not empty. So it displays restoring previous state from cookie. Restoring previous state from cookie. So what did I do? I took cookie value, decoded into raw data, and I repeated what I did before, displaying template for the raw result. Game result, raw data, and raw data recovered from the cookie. Okay? Questions? So this is how this works. I already mentioned that this is pure hack in order to join digits into string, right? What if we need to store name of a person? Name of a person potentially can have whatever characters in it, including spaces. Spaces are not allowed. So we need to do, or some maybe even comma not allowed as well. So for this reason, we need to do something better. So we need some conversion of any kind of string into the string that is acceptable in a cookie. Java comes with built-in conversions, so it's not a big deal. Okay? It's not a big deal, especially for string. So this is next. I'm switching branch from using a cookie to demonstrate potentially useful conversions. I'm switching branch to branch code fancy cookie encoders. Okay? Check out. In this case, I have the same interface. And as already mentioned, that how we implement it, it doesn't really matter, as long as it works. So for first one, I do exactly the same as in previous program. So it is just copy-paste. For second one, it's something else, but now I have 3 versions of it. And third, and now it's a challenge, because if we leave the code as the code is unchanged, Spring Boot doesn't know which one to use, logically, because we have 1 interface and 3 implementations. So it's ambiguous. If you leave it as it is, program will not start. It will start, say, ambiguity, blah, 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 don't know. So if we have more than 1 implementation of interface, we need to specify which one to use. So let's see. When I inject interface into controller, now I have to use qualifier that tells which one to use. Okay. So qualifier and name of the bean to be injected, Spring bean to be injected. As you see that it is like a name of the class, but starting with small letter. So this would be default name of the bean to be injected, name of the class. If we use, instead of add service, we would use configuration bean, that would be a method of a bean, method producing the bean. Name of the method producing the bean. Can we override it? Yes. It is just default values that we can override with extra code. For simplicity, I just decided to keep it as it is. Okay. Should I tell you how to override it? Yeah. So let's open one of the implementations. And here it is service. If we provide value, my bean, whatever, or my service, it doesn't matter. This would be qualifier for given bean. Okay. So now if I go to game controller, you will see that this is in red because I overrode the name and this default name doesn't work anymore. So now I need to use the one which I named in the bean. So my service. Okay. Now it is happy. So this is how to select the one what we want. And it is not just a matter of curiosity. We may think that why would we have more than 1 implementation inside of the same program? It looks like a theoretical exercise, but unfortunately it's not. Because sometimes we need to create an implementation of an interface in our code, just one in our code. But we use libraries that also has some implementation of the given interface that we don't want to use. But since it comes from the library, we need to be more specific that we want to use my own, not coming from the library. So for this reason, it is not just pure curiosity. Sometimes it is necessity. When we create the bean that we want to use, implementing some interface define it in the library, but library itself, where this interface is defined, also provides some default implementation that is too elementary to be useful. So this way we can override it. So it's not just a matter of curiosity, it is also useful. So let's see second implementation. So if we want to implement the second one, we will use cookie data service to read cookie data. Okay. So it would be second one for default name. So how would it work if I use this one? Let's see. I open it, and now I thought that what if it is some dice that have more than one digit on the side, because such exist. There are fancy dice that has more than one digit on one side, like 12, 15 numbers. You probably saw it, right? They're not squares, they have multiple sides. So in this case, we need to do something better, either use separator or use more general approach. So I decided to use a little bit more general approach. So I decided that if I use array of bytes, this would be good enough, because 1 byte is 255. It is unlikely that die will have a side number more than 255, right? So this would be overkill even. Why do I use array of bytes? Because array of bytes can be automatically converted into string, which is okay with cookies, okay with sending through web. And this algorithm for converting array of bytes, it is base64 encoding. Essentially, you can convert any binary, because any binaries can be represented as array of bytes, into something that you can be inserted into cookie or sent through web. But again, cookie is limited by length. So not everything can be inserted by cookie into cookie because it's limited in length. But for small piece of data, you can. So what did I do? I created array of bytes, and I know how many of them I need. It is length of the list. After this, I copy integers into array of bytes, but I need to do conversion. So first I convert it to int, after this I convert it to byte, because there is no direct conversion from integer to byte. So I have to chain them. And I assign this to array. After this I do base64 get encoder, encode to string, and it will create me string of encoded stuff. In this case, doesn't matter how many digits, right? It would do it. In order to go back, it is the same logic, but in reverse order. I got decoder. I decoded this into array of bytes. And after this, I'm going through array and building the list of integers. So one value from array of bytes, converting byte to integer, and adding this to the list. So this is list. Okay. And after this, I call constructor of raw data implementation with the list of integers, so it is. Now, as you saw, logic is not immediately obvious. Could be some mistakes, some data type mismatch, right? So this is where testing separately is important, okay? Because if we insert it into program and it fails, especially if program is not tested with different implementation, we don't know why it fails. So when we have some algorithm which could potentially have a bug, it is better to test it separately. So we know that that part was working, right? So right-click, generate test. edit to get, yeah, good test. Okay. Now, we can type the test methods annotated with test, but I already have some tests for first and for third, right? So let's, I want to copy some, where's my tests? Tests, cookie data tests. I already wrote it for first one, okay? And since interface is the same, if I use, instead of one, I use two, it should also work, right? Because it is the same, I'm testing the same thing. So what I would do, I would copy this from the first test, everything, into second test here. Okay. So what happens now? I created list of integers, but for the first one, it has to be single digit, right? Because otherwise, I was just joining strings. In this case, it doesn't matter. So I can just even put 12, and it should work, as long as it is smaller than byte, right? 107 even should work, because byte limit is 255, right? And it should work. So cookie data, instead, in order to create service, this is initialization, right? I'm calling cookie data service 2. Okay, but this is interface. So below I will use interface. So first part, I'm just checking that it's not, first test, I'm just checking that it's not crashing. There is no assertion in it. So what do? I pick input list and I print it. After this, I'm encoding it. Input list into raw data, because it expects raw data. Encode and print it. So let's see if it's crashing or not. So what happened? This is original list, just printed, it's no big deal. But this is encoded. This is how base 64 encoding would look like on the bytes, array of bytes generated from this list. So first it was just crash test. So it's not crashing at least. But for second, I want to do something more sensible. So I picked the array, I encoded it, so I got this string, supposed to be the same because I encoded the same way. Next, I took it and decoded backwards. So encode it and decode it. If it works correct, I should end up with the same stuff, right? So after decoding, I'm printing it. Raw data get values, I'm printing it. And I also compare original list with the one that I got after decoding. If it is matching, it means it works, right? If it's not matching, I'm in trouble. I need to fix this. So let's run it. The same, and this didn't cause exception, so it is working. All right? So this is a test of this algorithm. If we want to test it inside of the program, we need to run it again, but we need to remove cookie. Remember that it was crashing because it's not the same data. So I will remove this cookie. And I will run this program. No, when I click run, it is just running test, you see. I have to switch it, stop it. I have to switch it to raw data application because that was just running test. It did restart. Now I'm going to localhost 8080. Again, no cookie, no picture. Now, for roll, I got some encoded data. And when we use base 64 encoding, it is sequence of letters, some capital, some small. But it could be also double equal sign in the end, single equal sign, or no equal sign. It depends on the length of the data inside. It is for internal reasons, extra party. Okay. Questions? So if I go back to localhost 8080, it recovered the data from a cookie. So it is the same data. So that was reasonably automatic because almost anything can be array of bytes. There is also encoding for string called URL encoder. It is designed for encoding in URL, right? URLs. And after, luckily, it's lucky coincidence that cookies are also, cookie values produced by this encoding also have acceptable characters in it. So my second example for cookies also has this kind of encoding, URL encoding. This doesn't. One more fact. In the previous lesson, we learned about serialization. What is serialization? It's automatic conversion of object into 2-byte sequence of bytes. It is used to write binary files as sequence of bytes. If class is using only Java types, like integer, int, double, whatever, strings, you can mark it with serializable interface, and system can convert it to sequence of bytes automatically. It means you can take an object, convert it to a sequence of bytes, and encode that sequence of bytes using base64 encoder. So you will get acceptable string from any object, potentially, right? Serialize it and encode with base64. So this is what it is doing. 3. Okay. So if you need to serialize into file, you create a stream for a file. In this case, it's a stream to output into array of bytes. After this, you create another stream based on it, either based on array of bytes like here, or based on a file. After this, you write object into output stream, and this will be conversion. Please notice that this try and catch is very specific, unlike try and catch elsewhere, because you see that try has something in parentheses, and after this, block starts. This try with something in parentheses before try block is called try with resource. It is in Java since Java 7. How does it work? If exception is thrown, this object will be closed. A system will call .close on it. So the file will be closed even exception is thrown. And also, after going outside of this scope, this system will call .close on this object automatically. So it is convenience. Next. So this is what I mean. If this part is here, parentheses are not necessary, so it is regular try. Definitely we need semicolon in this case. And we will also have to do object output stream close. Because this is called automatically if you declare this inside of resource. This is what I mean. Next, you have try and catch. What would happen if I remove a try and catch? Of course, it won't catch exception if it would happen, right? This is our assumption, right? We typically put try and catch to catch exception if it happens, right? But it's actually worse than that. So let's remove try and catch. So I remove this part, and I remove this. So I'm getting rid of try and catch, right? So what happens? It's not compiling. I remember that in the beginning of the course, we learned that Java has special mean exceptions. They call it checked exceptions. That must be called explicitly with try and catch, otherwise code is not compiling. So all exceptions related to input-output, like file, like input-output exceptions, must be explicitly called in Java with try and catch. It's called checked exception. It is extremely annoying feature. We introduced it in Java, and after this, everyone was shocked how annoying it is. No other languages have it. So C# was created after Java, and by the time everyone was convinced that this feature is annoying. So it doesn't exist in Kotlin created after Java, but this is specific Java annoyance. It's called checked exceptions. It makes code a lot messier because of you either have to catch it or you have to rethrow it here and catch it elsewhere after that. So it is not really nice. So what is the issue? You see, it is complaining that IO exception is not caught or not rethrown by the method. Okay. So in order to fix it, I'll just go back. It's too much typing. Okay. I'm not changing this because I want to commit that. Okay. Roll back. This, I will commit it afterwards. So if I want to test this trick, I will go to my controller and I change this to 3, right? But I already learned from my previous experience I need to delete cookie. Otherwise it will crash. Delete. And by the way, I can also test it here because I already have test. Right? So I run test. And in the test, you will see that it is a lot longer than just encoding array of bytes. Why? Because integer is bigger than int, because it is wrapper around pure data. Integer, it's a class, so it's wrapper around int. But it's not just wrapper inside around int, and int is bigger than byte, obviously. Int is bigger than bytes, and we have wrapper around int, plus it's a list, which is also a class, that has additional data beside integer stored in it. So this is why it's a lot bigger. Okay? So here it is. And test is matching, so it's not failing. So what did we learn? If we have some non-trivial logic, we better test it separately, create test case and test it separately. Okay. Like this, right? It's definitely not trivial logic. So let's stop it. And now I switch it from test to application. Run. Start it. Localhost 8080, no cookies, no picture. Roll and see this is a cookie. It's a lot long, it's several lines. I'm going to remove this roll, going back to localhost 8080. Now it remembers data from cookie. So it read this data from the cookie and displayed it. So in the first half of the lesson, I mentioned URL encoding, but I never said what it means. It's just a quick demo what it means. If we look up at the example called hello user that was explained in class step by step, remember that multi-step example. So I'm picking last step. It is step 8. It is just very final one. And I run it. So it did start. This example doesn't have a cookie, any kind of cookie. So going to localhost 8080, it is first name, last name, okay, input with validation, right? So if I put just Jane Weasley, whatever, okay, and I click OK, you see that first name, Jane, at last name, and last name Weasley, right? So we got inputs in the address line as before. Now let's go back to input, and now I put Jane Weasley, but I want to use double name because some people do, like middle name, like Maria Jane Weasley, okay? It's possible. Maria space Jane Weasley. Maria space Jane Weasley. Perfectly valid name, right? So I click OK. And now you see, first name, Maria plus Jane instead of space. The reason is that spaces are not allowed inside of URL. So browser automatically encoded URL with space into URL without space. There is a naming convention how to get rid of characters that are not allowed in URL. This is called URL encoding. Okay. Such library exists in Java. So we can, if we want to store a string that contains not allowed characters, we can call this library and store it in a cookie. It is the same characters not allowed in URL, they are not allowed in cookies. So we can reuse this library. So this is what I mean. Okay, questions? So it's an additional option, but it works only for string, right? It's still, after this, is up to you to convert your object into string and call this URL encoder on the string. My second example for cookie has this URL encoder. So I will revisit this later. Questions? Okay. This space is plus will be automatically converted into space on the server. So we don't have to deal with it in our program. Our program will still receive Maria Jane. You see, there is no plus in it because it is converted automatically on the server, not our program. Server takes care of it.